Hi students, today we are going to discuss about antennas and propagation basics. So basics means regarding how radiation starts and types of radiations and everything. So coming to antennas and propagation, antenna is nothing but a transducer. It is a transducer which converts electric signals to EM waves or vice versa. It is a transducer which converts electric signals to EM waves or EM waves to electric signals, right? So here electric signals to EM waves. So electric signals to EM waves means it is a transmitter, or vice versa means it becomes a receiver. So this is one nothing but a simple an antenna. So what is propagation? After releasing these EM waves from antenna or receiving EM waves, so the propagation of these EM waves is simply called, this term as called propagation. So, how this transducer works? How this transducer works? So, how this transducer works means, coming to this point, you can basically classify this antenna into three types. That is omnidirectional antenna, isotropic antenna, and directional antenna. Out of this, isotropic antenna is an ideal antenna which radiates uniformly in all directions. That means it radiates like a sphere. It is an ideal antenna. It is an ideal antenna. It is used for only reference purpose. Coming to this omnidirectional directional antennas, that means you must be familiar about these terms like theta and phi. So theta means elevation angle. As you have already studied in EMTR, this is nothing but elevation angle. Phi is azimuthal angle. So azimuthal angle. So coming to these 2 points, elevation and azimuthal angle. If you take these coordinates x, y, and z, you take a free point in free space, any point in free space. Okay, you drop a normal onto the xy plane. You drop a normal onto the xy plane. So what happens means any angle made by the x-axis with that reference point on the plane is called azimuthal angle phi. Coming to elevation angle. Elevation angle means angle made by the point with respect to z-axis, that is called as theta. So if you are taking into consideration isotropic antenna, there are no limits for theta and phi. There are no limits for theta and phi. That means the antenna radiates in all directions. The antenna radiates in all directions. When coming to omnidirectional antenna, the antenna tries to radiate only in one parameter. So if theta radiates means phi doesn't radiate completely, or if theta doesn't radiate completely means phi radiates completely. This comes under omnidirectional antenna. Coming to directional antenna, both theta and phi are under control. That means the antenna radiates only in one specific direction. The antenna radiates only in one specific direction. Coming to real life examples, you can take here a candle source. It radiates uniformly in all directions. It is an ideal source. Omnidirectional antenna. Omnidirectional antenna means if you place a mirror here beside the candle, it tries to radiate in only one particular direction. You are able to control theta or phi. So it becomes a omnidirectional antenna. Directional antenna means it is very clear that if you take any torchlight source, it radiates a particular beam in at one particular point. This becomes a directional antenna. So, this is general basic classification of how an antenna radiates, radiation pattern. But how does an antenna radiate? How does an antenna radiate? So, to know this parameter, we have the basic equation called L into I dot is equal to Q into V dot. So, here coming length of the conductor, I means current, Q means charge, V means velocity. So in these parameters, if you take the current, if the current is DC, means it is not changing with respect to time, it is constant. So this type of antenna if you take, it cannot radiate. So first point it comes, the antenna does not radiate. Antenna does not radiate for DC. Antenna does not radiate for DC. Why? Because differentiation of DC current will become 0. Second point, if charges are not moving, Charges are not moving means there is no current. Charges are not moving means there is no current. So this equation becomes automatically 0. So the antenna does not radiate. Third one, the antenna radiates. The antenna or wire radiates under some three conditions. So what are those three conditions? First one, you can change the velocity. If you try to change the velocity of the charge carriers, then it tries to radiate. Second point, if you try to truncate the wire, then it radiates. Okay. If you try to load the wire, the wire tries to radiate. So these are parameters on how a wire tries to radiate. So in these two parameters, antenna cannot radiate. Okay. And last point in this is AC signal. That means alternating current. So what happens if you try to change velocity for a DC signal using truncation or loading methods? The wire tries to radiate. This is for DC. If you directly change the current to AC, means alternating current, the wire automatically radiates. So this is nothing but how a wire radiates. I will show you one basic example. So let us take a dipole. So what is a dipole means? It is having two polarities. If you take a wire, AC source, it is grounded. If you take a wire, so what happened is, here only one polarity will be developed, other polarity is grounded generally. So here, if you take a dipole means you are connecting simultaneously both positive and negative polarities to two wires. These are separated by a negligible distance. Where it creates the total length of the wire is capital L. So half of each wire is nothing but L by 2. So let us take a sine wave. Right? So this is first point, second point, cross point, third, fourth and fifth. Let us take some 5 reference points of how a dipolar wire radiates. Let us take this first point. First point indicates that there is no current. That means because there is no current, the antenna does not radiate. So if you observe here at this first point, there is no radiation. As the voltage is slightly increasing or current is slightly increasing, what happens means it is creating positive cycle polarities. Means this terminal becomes slightly positive, this terminal becomes slightly negative. So what happens in electromagnetics or electrostatics means if any positive charge and negative charge are existing at any point, they forms the electrical field lines starting from positive and terminating at negative. So here also same case exists. This is for second point. So here small type of radiation is generated. If you go to the maximum positive peak value of the voltage or current, means highest amount of voltage or current is generated, that creates maximum electric field line. If you are slightly moving towards again 0, what happens? The positive and negative charges existing on the antenna wire tends to decrease their strength. So what happens means the electrical field signal strength also slightly reduces. And coming to this 0 point, means there is no concentration of charges at that antenna polarity. So what happens means slightly these values move towards, and finally it becomes 0 means this wave gets detached. So it forms a one closed loop electric field for one positive half cycle. If you are taking negative cycle, same system exists. This is plus and this is minus. So electric field will start from bottom of the wire to negative of the wire, right? So this cycle continues until the end of the negative cycle. So after some time, if the negative cycle is completed, means this also will form a closed electric field line in this path. So if you take one positive and negative cycle of any signal, this forms a number of electric field lines. That means here one small example was given in practical life. So how a wire radiates means you can take a small pool or pond which is having stagnant water. Means there is no disturbance in the water. If we throw any stone into the water, then what happens means ripples will form. So these ripples continue until the energy is absorbed by the water. So same thing happens in antennas also. If you generate one pulse, that means if you generate one cycle, positive and negative cycle, the antenna tries to radiate completely into the free space until the signal energy becomes 0. So this is going to happen in case of antennas. In this way, the antenna tries to radiate EM waves into free space. So everywhere, wherever I said electric field line, it forms a closed path. Like this means horizontally magnetic field also will exist. Electric field line is like this, right? So magnetic field will be in a horizontal way, perpendicular to electric field. So everywhere these waves are generated. For a dipole, if you take for simplicity, you can see the radiation pattern like this. So all vertical lines represent electric field lines, all horizontal lines represent magnetic field lines. So this is nothing but a dipole radiation pattern. It is almost like an apple shape. It is almost like an apple shape. This is 3D type of radiation. This is 3D type of radiation. In textbooks, they will be given 2D type of radiation. We cannot represent everything perfectly using 3D. So 2D type of representation means you are taking an apple and making it into half. So seeing those two white parts, this is nothing but 2D type of representation of an antenna radiation. Next, so how these antenna parameters are measured? So basically, first parameter is nothing but directivity. So out of all parameters, the major parameter for antenna to measure is nothing but directivity. So how this directivity is measured? So directivity can be given as radiation intensity by radiation intensity in all directions. Radiation intensity to radiation intensity in all directions. So this also equals to 4 pi u by p rad. So this means power radiated uniformly in all directions to the radiation intensity in a given direction. So this means that if we are taking radiation intensity, so what is radiation intensity means? It is nothing but u of theta comma phi. So I said already isotropic antenna. Isotropic antenna. It radiates uniformly in all directions. But directional antennas do not generally radiate in all directions. That means these theta and phi parameters are controlled by the antenna through signal source. That means these theta and phi values change so that the directivity also changes. That means you can ideally take D equal to 1 for isotropic antenna. D equal to 1 for isotropic antenna. Because isotropic antenna radiates in all directions, U becomes U0, so it becomes value directly 1. So that's all, student, for this session. These are some basic how antenna radiates. Next class we will study about complete parameters of antennas. Thank you.